The electrodiagnostic system uses a differential amplifier to attenuate noise while amplifying the neurophysiologic potentials. It requires connections from three electrodes: active or E1, reference or E2, and ground. On most systems, these connections are color-coded with black for active, red for reference, and green for ground. The amplifier magnifies the difference in voltage between E1 and E2 electrodes. In this example, the E1 electrode is a monopolar needle recording a fibrillation with 50 microvolt amplitude. The E2 is a surface electrode and registers no significant potential. For simplicity, we consider this to be zero. The difference between these signals is 50 microvolts. Upon amplification, the signal is 5000 microvolts at the amplifier output. Now consider the same fibrillation potential in an ambient electromagnetic radiation that generates a 5000 microvolt noise. The noise is 100 times larger than the fibrillation. How can we record the fibrillation in presence of such noise? Note that the ambient noise is same at E1 and E2 electrodes. When subtracted, we get zero voltage, and hence the signal does not appear at the amplifier output. In this manner, the differential amplifier has managed to amplify the low voltage fibrillation while attenuating much higher voltage noise. In real differential amplifiers, the signals that are common to both inputs are not attenuated so perfectly. Some common signal does appear at the amplifier output, but with much less voltage. In this example, the common mode signal is 500 microvolts at the amplifier output. Note that the fibrillation voltage at the amplifier output is 10 times larger than noise, and we will have no difficulty in studying this waveform. A good differential amplifier should have a high gain for differential signals and low gain for common signals. These properties are expressed together as the common mode rejection ratio, or CMRR. A good quality amplifier has a high CMRR. This is illustrated using a simulation where we added high amplitude noise to a motor unit potential waveform. When the CMRR is 100 decibels, the motor unit potential cannot be seen clearly. Increasing the common mode rejection ratio reduced the noise. Increasing the CMRR by only 20 decibels made a significant difference, and we can see many details of the MUP waveform. Another important property of the amplifier is its input impedance. It should be high. Low amplifier input impedance gives more noise and artifacts. The best strategy for good recordings is to reduce the ambient noise and make it similar at E1 and E2 inputs. Furthermore, the electrode impedance should be reduced and made similar by cleaning the skin surface, applying the electrolytic gel, etc. This is described in greater details in other videos.